So here we have a spreadsheet that includes real-world climate data for Marquette, Michigan. So this comes from usclimatedata.com. And so anytime we're dealing with real data, there might be some cleanup that we have to do. So we're going to create some formulas, and we're going to see some of the issues that exist in the spreadsheet that make analysis a tiny bit difficult. For example, if we look at the precipitation column, it's the precipitation for month. So it keeps going up. This is getting bigger and bigger and bigger because it's a cumulative total, but we don't have the daily precipitation. The same thing happens with snow. We've got the average here, but we don't have daily totals. Sorry, we don't have the average. We have the cumulative total for the month. And you can see we've got January. The numbers get bigger. Then once we get to February, the numbers for precipitation and snow kind of reset, go back, starting at the baseline for that day. So here's what we want to do. Calculate the precipitation per day. All right, so this is going to be a little bit tricky. We can create a formula for January 1st. For January 1st, we're just going to create a cell reference to the precipitation for that day, the average precipitation. So the average January precipitation is 0.08 inches. Now, to find how much the average precipitation is on January 2nd, we can just subtract. So I'm going to say equals the value in D3, that 0.12, and I'm going to subtract the previous day's value. So that makes sense, 0.04. So if the average on January 1st is 0.08, the average on January 2nd is 0.04, that would give us a total of 0.12. So I can use the fill button here. I like using this instead of copying and pasting. I think it's just faster. And if I double click here, it's going to fill that down the entire column, which is going to be good. So it's giving me just spot checking, validating. Are these values correct? Yeah, they're all about the same, which is what you would expect. However, we run into an issue here on February 1st. The average rainfall on February 1st should be 0.04 inches, but we've got negative 1.77, because really what we're doing here is we're subtracting February 1st average precipitation from the January's total. So that's a problem. One fix that we can do here, probably the easiest way to fix this, is just to change the reference here to say equals February 1st. So that's going to reset that. This isn't a great practice because we have two different formulas in this column, which is not ideal, but it's probably the easiest way to fix this problem right now. Here we've got an issue, February 29th, so our leap year. This is an issue. This is a problem. What do we do with this day? Well, it kind of depends. You know what? We've got no snow, no rainfall. It just looks like the people who put this data set together just kind of punted on February 29th. Here's what I'm going to do. I'm going to cheat a little bit. I'm just going to delete that, pretend the leap year doesn't exist. So it screws up my formulas a little bit. So I'm just going to re-copy them by double-clicking that fill. And I'm going to go through, it's a little bit tedious work, but I'm just going to look for those first days of the month, and I'm going to clean these up. Now in practice, anytime you're doing data analysis, a decent amount of time is actually spent doing this kind of data cleanup activity. Very rarely do you get real data sets that are just perfect, have all the information you want. It's very common that you'll have to clean up this data. I'm going to pause the video and go through December. Okay, so I've gone through December and I've got all those values looking good now. I'm going to calculate the snow per day, and I'm going to do the same thing. First value is just going to be a reference to the monthly cumulative total. I'm going to copy that down, and it's going to, oops, sorry, I don't want to copy that down. In row 2, I'm going to subtract that value in row 2 from the value in row 3. And I'm going to copy that all the way down. And I should see, yep, first of the month, I've got that issue. So I'm going to do the same thing. I'm going to say equals on the first of the month. I'm just going to refer to that cumulative total. And I'm going to go down the entire column, the next 11 months of the year, and make that fix. So I'll pause the video so you don't have to watch me do that. Okay, so I've fixed that. So now I've got some other fields here that I want to fill in. So minimum rain per day. There should be, I would think, a day without rain, so the minimum is probably going to be 0. So if I say min precipitation per day, so here's how I'm going to select this whole range in column E. I'm going to click on cell E2. You can see it's going to fill that in my formula. And I'm going to hold down Shift, hit the End key, hit the down arrow, and it's going to jump one cell too far because I've got a formula down there. So I'm going to keep holding down the Shift key and hit the up arrow key one time to select the proper range. Then I'm going to close off that parenthesis. I'll have the minimum. So the minimum is 0.03. So on average, the minimum is 0.03 inches. So it wouldn't be 0 because it usually rains at least once per day over the span of several decades, let's say. So the maximum rain per day, we're going to do the same thing, equals max. I'm going to click on, well, I'll use the highlight method this time. I'm going to go to the bottom of my spreadsheet. I'm going to scroll way down, find that value. I froze row 1 to make it easier for me to see what I'm working with. I'm just going to scroll to the top to select that range. That's another way of doing it. The maximum average is 0.16, so you don't want to schedule your wedding for that day of the year. There's a much better chance that it's going to be raining. All right. If we want the most rain per month, we can look at the precipitation month column, and so that's going to be max. I'll show you why I don't like to select it down, because if I select precipitation per month and I go down, I have to select a whole lot of data, and then it's really easy to overshoot, and all of a sudden I'm in row 515, and I've got to go back up and try to go slow, and then I'm going to overshoot again probably, and then I've got to come back down. I just don't like doing that. So I'm going to close that off. All right. Most rain per month seems low, but it's what the data says, so I'm going to buy it. Least rain per month, so I'm going to use the min function. So my favorite technique, it's the Shift End method. I like using the keyboard. So what's the problem with this function? We know that no month has a true minimum of 0.04. In reality, we want to look at the last day of the month. So this is not going to be our actual range. So what's our min function going to take? Well, really we want to look at the last day of the month. So I'm going to hit, so go to January 31st, February 28th, all in column D, because it's the totals that I really care about. And this is a little bit tedious. There are some more advanced ways that we could do this, but using the tools that we're learning in class so far, kind of unfortunately, this is the best we've got. There would be, potentially some better ways to do this, but that's okay. This will work. September, October, November, December. So the minimum of those monthly totals is 1.3. So there's some month out there that rains at 1.3 inches. So the most snow per day, we're going to use the max function again. So snow per day. Make sure I'm at the top of my spreadsheet, Shift and down. And I'm going to ignore that value down there at the bottom. The least snow per day, we can do the minimum function. Most snow per month. Here the max works because the cumulative total is okay. So most snow per month, I'm going to look at the snow inch for the month, column G, go to the bottom, close to 30 inches, least snow per month. Okay, I'm going to cheat a little bit. I'm going to look at my least rain per month. I'm going to copy that whole formula. So I'm going to copy this inside the formula bar here so that when I paste it, hit escape. So when I paste it here in the formula bar, no cell references are going to change. So copying and pasting inside this formula bar will not update the references. But I want column G, so I'm going to change all the D's to G's because I know I already got the right rows before. To save me a little bit of scrolling and clicking, I'm just going to use this method here. Least snow per month, 0 inches. That makes sense. Month of August, it's probably not going to snow. Now, one function I can use to find the standard deviation of the population of the high temperatures, I can say stdef.p function and just look at those high temperatures. Too many decimal places for me. I'm going to clean that up a little bit. Looks good. I'm happy with the way that this looks. Let's take a look at the very bottom of the spreadsheet though. There's some leftover stuff there, like what's going on? I'm going to do end down to jump to the bottom. I'm just going to delete that. I don't need that there. So what is this sum? Let's just sum up the daily temperatures. Oops. And I was accidentally creating a circular reference. I'm going to add up the precipitation for every day. What does that tell me? 29 inches of rain per year. Seems about right for Marquette, Michigan. Okay, so that's a few formulas, some data cleanup and things that we have to do a proper data analysis, but I'm happy with the way that this spreadsheet is looking.